In this section, we're going to look at stem and leaf plots as well as percentiles. A stem and leaf plot is a special table where each data value is split into a stem, the first digit or digits, and a leaf, usually the last digit. Let's look at this example, and we're going to construct a stem and leaf plot. We first want to organize the numbers from smallest to largest, and it is already done for us. Now the first part of the number is going to be our stem. Looking at the values in the data set, we realize we have a range of 1 to 4. So for the stem, I'm going to put my numbers as 1, 2, 3, 4, since the front number of each data value has either a 1, 2, 3, or 4. For the leaf, I'm going to look at the last digit. 15 is represented like this, 1 on the stem part and 5 on the leaf part. So this represents 15. 16 is going to be written like this, 1 and a 16. So this represents 16. We have 21. The stem is 2 and the leaf is 1. 22. The stem is 2 and the leaf is 2. For 23, we have the leaf is 3. 26 and 26 appears twice, so we have to represent 2 leaves with 6 and 6. We have 30, so that's going to be a stem of 3 and a leaf of 0. 32, a stem of 3, a leaf of 2. And finally, 41 is represented by a 4 for the stem and a 1 for the leaf. In this case, our leaf unit is equal to 1. That means this number on the leaf side represents the ones place. So the reader knows 1, 5 represents 15. Example, construct a stem and leaf plot for the following data. Use leaf unit in the thousands. Notice that we want the leaf unit in the thousands because our numbers are much larger than the previous example. So I'm going to locate the thousands position, and for the first number, that's going to be the 2. And I want to draw a vertical line just to the left of that 2. And for each number, I'm going to locate the thousands position and draw a vertical line to the left of that. $3,000 has no number in front of it, but I'm still going to draw a vertical line in front of the 3. And now we know how to construct our stem and leaf plot. When you construct a stem and leaf plot, make sure you always start with the smallest value first. The smallest number here is 3,000. Notice that there's no number in front of the 3 for the stem, so we're just going to add a 0, or sometimes you can leave that blank. So the stem is 0, and the leaf is 3, and our leaf unit, remember, is in the thousands, so this represents 3,000. The next smallest number is 12,000, and we have it repeated twice. I'll write it as a 1 and a 2 for 12,000, and another 2 since we have two 12,000s. The next number that we need to put on our stem leaf is 23,000, and we'll put a 2 and a 3 for the leaf. We can continue the process. 32,000 is represented by a 3 and a 2. 36,000, we're just going to add an additional 6 for the leaf. Now we have 45,000, which is represented by 4 and a 5. And now we don't have any number that is in the 50,000s range, so we're going to just continue to the next number, which is 9. We'll put a 9 for the stem, and the leaf is 4. And this is our stem and leaf plot for digits in the thousands. Example, consider the grades for a class written in stem leaf form. What was the original data set, assuming the leaf unit is ones? Now, I want to translate this back to the original data, so we'll start with the stem. 1, 2 represents 12. 1, 3 represents 13. And we could continue the process and decipher the original data set. 2, 1 represents 21. We have 27. 3, 3 represents 33. 3, 4 is 34. 35. 37. 4, 0 represents 40. We have another 40. And finally, we have a 41. So this is the original data set. Let's look at more definitions. The median, denoted with the letter M, is the middle value of an ordered set. The minimum is the lowest value in the data set, and the maximum is the highest value in the data set. In order to find the median, we must first order the data set from small to big. Then we have to find a number such that there are exactly as many values above it and below it in the data set. Example, sibling data 0, 2, 1, 5, 7. Here n is equal to 5, which means our sample size is 5. Find the median, minimum, and maximum. First, we need to order the data set from smallest to biggest. So we'll say 0, 1, 2, 5, 7 is the order from smallest to biggest. The minimum is really easy to find. It's the smallest value. That is 0. The maximum is the next easiest value to find. That's just 7. Now the median is the number that's right in the middle, and you can clearly see that 2 is in the middle where we have 2 data values below it and 2 data values above it. So the median is equal to 2. Example, find the median, minimum, and maximum. Again, we have the sample size is equal to 7, and I want to arrange these values from smallest to biggest. The smallest number is -3, then we have -1, 0, 5, 5, 7, and 9. To find the minimum, it's going to be the smallest value, that's just -3. To find the maximum, that's the largest value, that's just 9. The median is the number right in the middle, so we have 5 is directly in the middle with 3 data values below it and 3 data values above it. The median is 5. Consider the following. We have the data set 12, 3, 11, 17, 5, 4, 201, and 0, where our sample size is 8. Find the median. In this case, 8 is an even number, so we're going to have to figure out what to do with the median. We will arrange the data values from smallest to biggest, and we'll have 0, 3, 4, 5, 11, 12, 17, 201. And now, in order to find the median, we'll look for the number that's right in the middle. In this case, we have 2 numbers in the middle, 5 and 11. if we have an even set, to find the median, we have to add these two numbers and then divide by 2. So if it's an even set, add the two numbers in the middle and then divide by 2. This gives us 16 divided by 2, which is 8. The median is 8. What is a percentile? Well, let's consider the 95th percentile. Let's suppose we took an exam and we scored at the 95th percentile. That doesn't mean we had a score of 95%. The 95th percentile means we beat 95% of the population. So of the exam, we beat 95% of the students who took that test. The quartiles divide the data set into quarters. The first quartile, Q1, has 25% of the data below it. The second quartile, Q2, which is also known as the median, has 50% of the data below it. And the third quartile, Q3, has 75% of the data below it. We therefore say that the third quartile is also the 75th percentile, and the first quartile is the 25th percentile. Example, for the following data, find the minimum, Q1, median, Q3, and the maximum. First thing we want to do is to find the easiest values to look for. The minimum is the smallest value, and that's going to be the 20. The maximum is going to be the highest value, and that is 40. But make sure the data set is arranged from smallest to biggest before you determine the minimum or maximum. Looking at the numbers, I notice that the sample size is equal to 14. So we'll look at the two middle numbers, and that's going to be 32 and 33. So to find the median, we're going to take those numbers, add them up, and divide by 2. So the median is 32.5. To find Q1, we have to cut the data in half and find the median of the first half. The median of the first half is 28. It is directly in the middle of the first half, so Q1 is 28. Q3 is going to represent the median of the second half, so when I split the data in half, the number that is directly in the middle is 38. So Q3 is 38. So we have the min is 20, Q1 is 28, the median, or also known as Q2, is 32.5, Q3 is 38, and the maximum is 40. Example, find the 25th, 50th, and 75th percentile from the following list of 30 data values. I will start with the easiest question, and that's the 50th percentile. This means I'm looking for a number in the data value that has 50% of the data below it and 50% of the data above it. I want to find essentially the number right in the middle. If I organize the data set from smallest to biggest, I'm looking for the number right in the middle. We notice that the sample size is 30, so we say that the sample size n is equal to 30, and I want to find the number in the middle of that. I will take 30 and multiply by 0.5, which is equivalent to 50%. 30 times 0.5 is 15, so I know in the 15th position, we're going to find the 50th percentile. Looking at the data values, I know that the 15th position is 50. So for the first solution, we have the 50th percentile is 50. For the second part of the question, we'll look at the 25th percentile. We will take the 30 and multiply it by 0.25 to find a number that has 25% of the data below it and 75% of the data will be above it. 30 times 0.25 is equal to 7.5, and that means the 7.5th position is going to be our 25th percentile. But how can we have a 7.5th position? This means we're going to look at the 7th and 8th position to find our 25th percentile. And those numbers in the 7th position and 8th position are 22 and 31. To find the 25th percentile of these two numbers, we'll take the average. So we'll add 22 plus 31 and divide that by 2. This gives us 26.5, and that's going to represent the 25th percentile. This means that 25% of the data is below 26.5 and 75% of the data is above 26.5. For the last question, the 75th percentile, we're looking for a number that has 75% of the data below it and 25% of the data above it. So we'll use the same process. We'll take 30 and multiply it by 0.75 because I want to look for the 75th percentile. This number is equivalent to 22.5, which means I'm looking for the 22.5th position, which is the same as the 22nd position and 23rd position. The 22nd and 23rd position are 60 and 61. So to find our 75th percentile, we'll have to add these up and divide by 2. 60 plus 61 divided by 2 gives us 60.5. So this represents the 75th percentile. We have 75% of the data must be below 60.5. This is the 75th percentile. In this example, we want to find the 84th percentile, P84, from the following data values. Now, if you count all of the data values, our sample size is 35. Now I want you to pause the video and try to see which number is the 84th percentile. To find the 84th percentile, we'll take 35 and multiply that by 0.84, which is 84% as a decimal. This gives me a value of 29.4, and I know the 29.4th position represents the 84th percentile. Since there is no such thing as the 29.4th position, we're looking for the 29th and 30th position. So the 29th position is 74 and the 30th position is 75. Remember, you have to make sure the data value is from smallest to largest. And now we'll have to add these two numbers up, 74 plus 75, divide that by 2, and that will give us our 84th percentile. And this is equivalent to 74.5, which means 84% of the data is below 74.5. 74.5 is the 84th percentile, which means 84% of the data is below 74.5.